Hello dear students, this is your physics Jagan sir. Welcome to our YouTube channel Physics with Jagan sir. And today onwards we are going to start new chapter kinematics. And we had already successfully completed kinematics and we had successfully completed vectors chapter along with some numerical values. Okay. Now next point is, see here, in kinematics first of all we must know what is frame of reference. Here the frame of reference means frame of reference from where observations made, that is frame of reference. Suppose I will give you an example for your clarity. See here, a bird is present here, and this bird, suppose observed from an observer who is at this location, then the position of the bird with respect to this person is, let us assume, r distance, and the platform from where he is observing, that is known as reference frame or frame of reference frame or frame of reference. Okay, frame of reference. And next point, here he is at rest position, and it is not always the condition that frame of reference remains at rest position, because let us see an example. If a person is traveling in train or bus, he is inside it, a table is present. On the table, suppose a cup is present, and here the candidate is moving with the same moving in the same bus with certain amount of velocity, suppose 30 meter per second or 30 kilometers per hour. Of course 30 meter per second is not possible. 30 kilometers per hour. If this with or if the candidate is moving, the bus is moving with this amount of velocity, he would feel that the cup is at rest only. And if a tree is present here, he feels himself that the tree is moving in the backward direction with respect to him. With respect to, the word says, the from where he is making calculations or from where he is doing observations. Okay, now that observation from where he is making is acting as the frame of reference. Okay, this is what is frame of reference. Then next one is equation of trajectory. Next concept is equation of trajectory. See here, suppose an object is moving from here to here by following this path. Let us assume the path followed is known as trajectory. That is path followed. Now next one is trajectory equation. What is trajectory equation? Representation of that trajectory by mathematical representation is trajectory equation. See here, suppose the same line is representing like this, and it is x-axis, and this is y-axis. Now here the trajectory equation is function of x and y. This is a function of both x as well as y. Now we can use an example for your clarity. Suppose A particle moves in xy plane such that its position vector varies with the time. Position vector is 2 sine 3t 2 sine 3t I plus 2 1 minus cos 3t j. Find the equation of trajectory of the particle, that is trajectory equation. Now let us assume that r is equals to xi plus yj. I am representing r. I am comparing with xi plus yj. Now it gives x value as 2 sine 3t. I can also write it as sine 3t is equals to x by 2. Let it be equation number 1. Similarly, 2 1 minus cos 3t is equals to y 1 minus cos 3t is equals to y by 2. 1 minus y by 2 is equals to cos 3t. Okay, let it be equation number 2. Now by using equation 1 and equation 2, here can I say sine square 3t plus cos square 3t is equals to x by 2 whole square plus 1 minus y by 2 whole square. And we know from trigonometry sine square theta plus cos square theta is equals to 1. Then this is equals to 1 is equals to x by 2 whole square plus 1 minus y by 2 whole square. So this is the function of x and y. This is equation is representing in terms of x and y. This is how we have to write trajectory equation. Trajectory equation. Probably you might be understanding very clearly, right? Then next one is, see here, distance and displacement. Next concept is this distance. First of all, let us see distance. Suppose it is point A, it is point B. A candidate or an object is trying to move from A to B, either of like this, either of like this, either of like this, whatever the path he can follow, and he can move from A to B. Now see here, this is path 1, this is path 2, this is path 3. The path followed by the path followed by the object is known as distance, is known as distance. So distance is equals to the path followed by the object. Then next one is, what is displacement? What is displacement? Displacement means the shortest path followed, the shortest path followed by the object. See here, the shortest path followed by the object means here we have three paths, number 1 path, number 2 path, number 3 path, and out of these 3 paths only second path gives the shortest separation between A and B. And out of these 3, not only out of these 3, do we have any other option to represent the separation between A and B instead of 2? No, it is not possible. So the second path exactly represents the shortest separation between A and B. Therefore we consider it as displacement. And here you can catch a point. Most important point is distance value sometimes equals to displacement values, and sometimes it is greater than displacement values also. So distance is greater than or equals to displacement. Okay, right. Then next one is, let us see an example over this concept, distance and displacement. Suppose, see here, r1 r2, angle between these two is theta, and this is delta r. And Here, a particle moves from position A to position B in a path as shown in the figure. If the position vector r1 and r2 making an angle theta between them are given, find the magnitude of the displacement. That means, see here, this is the path followed by the object. This is the path followed by the object, and this is actually distance value. But they are asking us to find displacement. Displacement means separation between these two points. Separation between these 2 points. Now, see here for R by using above diagram, it is forming R1, like it is the initial position, it will be the final position, suppose. So R1 plus delta R is equals to R2. R1 delta R, so it is coming like this or like this. So R1 plus delta R is equals to R2, and next part, delta R is equals to R2 minus R1, R2 minus R1, and they given that the angle between R2 minus R1 is theta. Therefore resultant is equals to under root of R2 square R1 square 2R2 R1 cos theta, but it is negative sign. So here it should be R1 square minus 2 R1 R2 cos theta. This is the displacement value. This is the displacement value. Displacement. The required displacement delta R is equals to under root of R2 square plus R1 square minus 2 R1 R2 cos theta. And by how I am writing this one, we had successfully completed in our vectors chapter. Probably that might be in our second class of the vectors chapter. So there you will find subtraction or addition of vectors, and how I am using or how I am writing this one like this, you will get the clarity in that class. So you can go to that class and listen that class, you will get the idea. And next part is, we will see one more example here. Let us assume a particle moves in a semicircular path of radius r from O to A, like this, from O to A, first point, like this. Then it moves parallel to z axis covering a distance r. See, again I am drawing for our clarity. A to, right, O, let us assume it is P, and this is parallel to z axis covering a distance r up to B, covering a distance r up to B point. Finally, it moves along the BC parallel to y axis, along the BC like this, parallel to y axis. So path is like this, and like this, and they mentioned it 2r is the distance. This distance is 2r. This distance is 2r, right? Then find the ratio of distance by displacement. They are asking us to find ratio of distance by displacement. See here, distance is the path followed by the object. So path followed by the object is OP, that is O to P plus P to B plus B to C. The topmost point is C, B to C. Then the path followed from O to P is, can I say, half of the semicircle means pi r plus P to B, that is given as R, then B to C, that is given as 2r. So distance is equals to pi plus 3 of r. This is what is distance. Okay, distance. Now they are asking us to find displacement. For finding displacement, and obviously we know that displacement is a vector. So we have to represent the displacement in terms of vectors. On x-axis, the final position of the object, on x-axis, its value is 2ri, and on y-axis, its position is on y-axis, its position is 2rj. On z-axis, its position is r. So rk. Okay, rk, right? Then displacement is equals to magnitude of 2r square plus 2r square plus r square, which is equals to 4 plus 4 plus, right, 9r square, which is equals to 3. Then the required answer is distance. This is displacement. Then distance by displacement is equals to pi plus 3 r by 3r, which is equals to pi plus 3 by 3. This is the required answer. Okay, right. Similarly, let us go with the next question. A particle moving in a circle of radius r, suppose it is circle of radius r, what is the displacement when it covers half the circle? That means if object starts its journey and moving like this and reaches this point, and first of all they are asking us to find displacement. So displacement is equals to when it's, right, when what is the displacement when it covers half of the circle? That means initial position is this one, final position is this one. So this is displacement 2r. So displacement is 2r for half circle, right? Then for full circle means object starts at this point and again comes to the same point. So total displacement is 0 for full circle. Number 2, B part of the question, what is the distance when it covers half circle? Distance half circle means from here to here only, that is pi r. Then this is for half circle, and distance is equal to for complete circle 2 pi r for complete circle. These are the distance and displacements for the object which is circulating in the circle. And this is what is the class about trajectory and distance and displacement of the kinematics chapter first class. And if you have any queries, you can notify me through our YouTube, and you can follow Physics with Jagan sir Telegram channel for your daily material and weekend examinations. Have a great day. Take care. Bye bye.